Good morning, students. Am I audible, visible? Hello. Am I audible? Are you getting my voice? Hello. The last class I have discussed about absolute value function. Today we'll start with the signum function. Okay. Random signum function. It is defined as signum x SGN, denoted by SGN, equals mod x upon x if x not equal to 0, 0 if x is equal to 0. Signum x is defined as mod x upon x if x not equal to 0, 0 if x is equal to 0. We can redefine mod x upon x. If x is greater than 0, mod x is equal to x. If x is less than 0, mod x is negative x. So we can redefine the function as minus x upon x if x less than 0, 0 if x is equal to 0, x upon x if x greater than 0. So this is equal to minus 1 if x less than 0, 0 if x is equal to 0, and 1 if x greater than 0. This is called signum function. So domain of the function is R. Domain f is equal to R. And the range of the function is equal to minus 1, 0, and 1. The range of the function is minus 1, 0, and 1. And the graph of the function is for positive values of x is equal to 1, y is equal to 1. For negative value of x, and for x is equal to 0, functional value is 0. So graph of the function is, this is x is equal to 1, sorry, y is equal to 1. This is y is equal to minus 1 and y is equal to 0. This is the graph of the function, graph of signum function. Okay. Then come to greatest integer function. Greatest integer function. It is denoted by y is equal to f of x is equal to bracket x, which is defined by bracket x is equal to x if x is an integer bracket x is equal to x if x is an integer just below x
କହୁଛେ ନାଲି ନା ଖଇରିଆ
if x is not an integer. Bracket x is equal to x if x is an integer just below x if x is not an integer. So bracket value of 2, since 2 is an integer, bracket value of 2 is 2, bracket value of 4 is 4, bracket value of minus 5 is minus 5, okay, bracket value of 2.9. 2.9 is not an integer, so its bracket value is the integer just below 2.9. Integer just below 2.9 is 2. Bracket value of minus 4.6. Bracket value of minus 4.66 is not an integer. So integer just below minus 4.6 is minus 5. So we can write bracket x is the greatest integer bracket x is the greatest integer among the integers those are less or equal to x. Those are less or equal to x. Okay. This function is also known as jump function, staircase function, post office function, lefty function. Okay.
ସେଟା ତୁ ଯିବୁ ଯାଉନୁ ମମି କ ସେ ଘରେ ନେଇଛି
The value of x.
ଆଉ ଯୋଉ କହୁନୁ ମୁଁ ଏକ ଅଧାରେ ଉଠିକି ଯିବି
ହେଲେ କିଏ କଥା ହଉଛ? If the value of x lies in the interval 0 to 1, bracket x is 0. If the value of x lies in the interval 1 to 2, bracket x is 1. If the value of x lies in the interval 2 to 3, bracket x is 2. If the value of x lies in the interval n to n plus 1, bracket x is equal to n. This function is defined for all real values of x. Hence, we can write domain of the function. Domain f is equal to r. Range f is equal to integers or z. When we come to graph of the function, zero, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, 1, 2, 3, when x lies in the interval 0 to 1, bracket x is 0. When x lies in the interval 1 to 2, bracket x is 1. When x lies in the interval 2 to 3, bracket x is 2. When x lies in the interval 3 to 4, bracket x is equal to 3. When x lies in the interval -1 to 0, bracket x is -1. This is the graph of the function y is equal to f of x is equal to bracket x. Let's write down properties of greatest integer. Properties of greatest integer function. Bracket x is equal to x. If x is an integer, bracket of minus x is equal to minus of bracket x. If x is an integer, minus bracket x minus 1 if x is not an integer. Okay, then third property is bracket of x plus I is equal to bracket x plus I, where I is an integer. Bracket of x plus I is equal to bracket x plus I, where I is an integer. This implies bracket of x plus bracket of x plus bracket of x plus n times is equal to n of bracket x. Property 4, bracket x is equal to k implies x belongs to k to k plus 1. Bracket x is equal to k implies x belongs to k to k plus 1. Property 5, bracket x greater equal to k implies x greater equal to k, bracket x less equal to k, implies x less than k plus 1. These are the properties of greatest integer. Now let us come to solve a couple of questions. Find the domain of following functions. The first question is find the domain of the function f of x is equal to 1 upon under root bracket x minus 5. The second one is f of x is equal to under root bracket x square minus 5 bracket x plus of 6. So guys, try to solve these questions. Send me the answer through the chat box. Come to the solution. Question number 1. F of x is equal to 1 upon under root bracket x. Rahil Patnaik function is 6 to infinity. Yes, you are correct. Sahil, you are correct. Bracket x minus 5. So bracket x minus 5 is greater than 0. Bracket x greater than 5. This implies x belongs to 6 to infinity. Sahil, you are correct. Try to answer the question number 2.
मैम से टीचर को वॉइस असुरी
Right, what is the answer to question number 2? What is the domain of the function f of x is equal to under root bracket square? Yes, minus infinity to plus infinity. Domain of the function is R. You are correct. Okay, let me solve the question number 2.
ठीक है
F of x is equal to under root bracket x square minus 5 bracket x plus 6. This is the question, eh? So bracket x square, under root expression function to be defined. Under root expression should be greater or equal to 0. Here the under root expression is bracket x square minus 5 bracket x plus 6 greater or equal to 0. Okay. So this can be factorized as bracket x minus 2 into bracket x minus 3 greater or equal to 0. Applying the Weber method. So critical point are 2 and 3 plus minus plus. So bracket x, the function to be defined, bracket x should lie in the interval minus infinity to 2 union 3 to infinity. Bracket x should not lie in the interval 2 to 3. You know, bracket x is an integer, so it can't lie in the interval 2 to 3. So for any, if you take x, any real number, either it will be minus infinity to 2 or 3 to infinity. It can lie in the interval 2 to 3, hence domain of the function is R. We can write domain of the function is R. It is not possible that bracket x will lie in the interval 2 to 3. I hope it is clear to you. Then come to fractional part function. So, okay, solve 2 or more questions on range. Question, write down question. Find the range of the following functions. Okay, these are the 3 questions.
find the condition function
Come to the solution. F of x is equal to bracket of sin x plus cos x. F of x is equal to bracket of sin x plus cos x. You know, sin x plus cos x, maximum value of sin x is root. If f of x, let us consider g of x is equal to a sin x plus b cos x, and max value of g of x is equal to maximum value of g of x is equal to under root a square plus b square. Minimum value of g of x is equal to minus under root a square plus b square. Maximum value of g of x is under root a square plus b square. Minimum value of g of x is equal to minus under root a square plus b square. So here a is equal to 1 and b is equal to 1. So sin x plus cos x lies in the interval minus root 2 to plus root 2. Sin x plus cos x lies in the interval minus root 2 to plus root 2. You know, approximate value of root 2 is 1.414. 1.414. So this sin x plus cos x lies in the interval minus 1.414 less equal to sin x plus cos x less equal to 1.414. So its bracket value will lie in the interval minus 2 to 1. So range of the function is minus 2 to 1. Range of the function is minus 2 to 1. Okay. Abhinash, Srijit, is it clear? Subhalakshmi, write in the chat box, is it clear? The second one is f of x is equal to bracket of f of x is equal to bracket of x cube minus x. You know, x cube minus x is an odd degree polynomial function. Range of an odd degree polynomial function is R minus 1, 0, 1. Range of an odd degree polynomial function. So graph of the function x cube minus x is like this. So minimum value, minimum and the maximum value doesn't exist. Okay. It lies in the interval minus infinity to plus infinity. Its bracket value will be all integers. Okay. So range of the function is equal to z. Range of the function is equal to z. Then third one, f of x is equal to bracket of or box of x square plus x plus 1. X square plus x plus 1 is a second degree polynomial function. And you know, if f of x is equal to ax square plus bx plus c, then range of the function is minus d by 4a to infinity if a greater than 0. Here a is greater than 0. Let us consider g of x is equal to x square plus x plus 1. So its range will be minus d by 4a. D is equal to b square minus 4ac minus d is equal to 4ac minus b square. 4ac is 4 minus b square 1 by 4 to infinity. That is 3 by 4 to infinity. 3 by 4 to infinity. 3 by 4 is less than 1 and its bracket value will be 0 to all integers, that is equal to range f is equal to whole numbers 0, 1, 2, 3 up to infinity. Okay. Quickly note it down. Srijit, is it clear? Abhinash, Subhasri, okay. Then come to fractional part function. Fractional part function. It is defined as curly bracket x, which is defined by curly bracket x equals x minus bracket x. Okay. That means fractional part of the number. Suppose curly bracket 2.6. Curly bracket of 2.6 is equal to 2.6 minus bracket value of 2.6. Bracket value of 2.6 is 2.6 minus 2, which is equal to 0.6. 4.3 fractional part will be 4.3 minus bracket of 4.3. Bracket of 4.3 is 4. 4.3 minus 4. Please, କିଏ କଥା ହଉଛ? କାହାର ଅଡିଓ ଖୋଲା ଅଛି? Okay. So bracket x, fractional part of x always lies in the interval 0 to 1. Fractional part of x always lies in the interval 0 to 1. The domain of the function is R. It is defined for all real numbers. Range f is equal to 0 to 1. Domain of the function is R. Range of the function is 0 to 1. Then come to graph. Graph of fractional part function. Zero, 1, 2, 3, minus 1, minus 2, this is 1. Okay. This is the graph of fractional part function. if you want to redefine it branch wise, in the interval 0 to 1, fractional part of x is equal to x. In the interval 1 to 2, fractional part of x is equal to x minus 1. In the interval 2 to 3, fractional part of x is equal to x minus 2. In the interval minus 1 to 0, fractional part of x is equal to x plus 1. Okay, algebraic function complete, then come to transcendental functions. Their previous class करिनी. अच्छा, शुभलक्ष्मी काई करनथिला? शुभलक्ष्मी रीजन को काई प्रीवियस क्लास करिनो? ई क्लास गुडा करे सबु क्लास गुडा अटेंड न करिवो बुझा पड़िबोनी, प्रॉब्लम हबो. ठीक अछि, आज तो फंक्शन कंप्लीट हे जो. लिंक काई पाइ नथिला तमको हाई सेकेंडरी स्कूल? शुभलक्ष्मी, you are from which higher secondary school? कटक सेकेंडरी स्कूल. ठीक अछि, मु जणेबी जे कोऑर्डिनेटर अछंती तम पाखरे केमति लिंक ठीक ठाक पहुंचबो. आज तो फंक्शन कंप्लीट हे जबो. ई फर्स्ट सेशन रे माने 7:30 to 9 जो सेशन अछि. देन जो 9 to 15 to 10:45 जो सेशन अछि सेठी मु ट्रिगोनोमेट्री आरंभ करिवि फ्रॉम बेसिक टू एडवांस लेवल. और सेटा सबले जॉइन करिवो. बहुत पिला कोन कोन फर्स्ट सेशन जॉइन करउते, सेकंड सेशन को एब्सेंट रहि जाउते. तेणु सेमती हेले किछि बुझि हबनी. जदि तुम यादरु किछि बेनिफिट पाइबाकु चाहूछ, कंप्लीट सब क्लास अटेंड करो. सब क्लास अटेंड कर तुम जानि परिबो. एवं तुम भी डाउट भी पचारि परिबो, डाउट भी पठेई परिबो मो पाखु. मु तुम डाउट भी क्लियर कर परिबे. आ तुमर किछि डीपीपी दरकार, डीपीपी भी सेंड कर देबी. बुझेला शुभलक्ष्मी? Then come to transcendental functions. Transcendental functions. Functions comes under transcendental functions are exponential function, logarithmic function, trigonometry function, and inverse trigonometry function. So let's start with exponential function. Exponential function. It is defined as y is equal to f of x is equal to a raised to the power x. What is a? A is a constant and it is greater than 0. A greater than 0 and a not equal to 1. If a is equal to 1, then the function will be constant function. It is defined as y is equal to f of x is equal to a raised to the power x. For example, y is equal to f of x is equal to 5 to the power x. Y is equal to f of x is equal to 4 to the power x. Y is equal to f of x is equal to 0.5 to the power x. All these are exponential functions. Okay. So if you consider f of x is equal to 5 to the power x, so if you want to get the value of f of x at x is equal to 0, then consider the function f of x is equal to 5 to the power x. If you take x is equal to 0, it will give you f of 0. F of 0 is equal to 5 to the power 0 is equal to 1. F of 1 will be 5 to the power 1. It will be 5. So you take any real value in place of x, you will get a unique value. Okay, because 5 to the power x is defined for all real values of x. So we can say that domain of an exponential function is R. Write down domain of an exponential function. An exponential function is defined for all real values of x. Clear? Then come to what is the range of the function. Since a is a positive real number, a to the power x, okay, any power of a positive real number, whether it is positive power or negative power, any power of positive real number is greater than 0. A power x is greater than 0 for all x belongs to R. Hence, we can say that range of the function is R. Sorry, range of the function is R plus set of positive real number. Range of the function is R plus, that is set of positive real number. Just a minute, guys. Okay. Then come to graph. Before going to draw the graph of an exponential function, we should analyze an exponential function. Exponential functions are of two types. One is increasing exponential function. Second one is decreasing exponential function. Increasing exponential function, decreasing exponential function. Subhasri, is it clear? Write down exponential functions are of two types. Exponential functions are of two types. एक रहेला increasing exponential function, increasing exponential function. Second one is decreasing exponential function. Increasing exponential function. Second one is decreasing exponential function. Okay, the increasing, decreasing nature of an exponential function depends upon its base. F of x is equal to a raised to the power x. If the value of a, I've told you, that is a is greater than 0 and a is not equal to 1. A is greater than 0 and a is not equal to 1 means either a will be in the interval 0 to 1, either a belongs to this interval, that is 1, 0 to 1, or a belongs to 1 to infinity. Okay. When the base a, that is lies in the interval 0 to 1, the function is a decreasing function. Let's come to a particular case. Suppose f of x is equal to 0.5 to the power x. F of x is equal to 0.5 to the power x. If you take x is equal to 0, y is equal to f of x is equal to 0.5 to the power x. If you take x is equal to 0, then the value of y will be 0.5 to the power 0 will be 1. If you take x is equal to 1, then the value of y will be 0.5. If you take x is equal to 2, then the value of y will be 0.25. If you take x is equal to 3, y will be 0.125. X is equal to 4, y will be 0.0625. Right? So when the value of x increases, the value of y decreases. So the function is a decreasing function. If there is a inverse variation, between the independent and a dependent variable of a function, then you can say that the function is a decreasing function. For increasing value of x, we will get the decreasing value of y. When x increases, that means x moves from left to right in the x-axis. Then y decreases, y moves to downward in the y-axis. Okay. So this function is called decreasing function. So write down note point 1. If a belongs to 0 to 1, the function f of x is equal to a raised to the power x. When a belongs to 0 to 1, the function f of x is equal to a raised to the power x is a decreasing function. Okay. The graph will be like this. This is coordinate system. From the graph, it is clear that when x approaching towards negative infinity or minus infinity, f of x or a raised to the power x approaches to infinity. We can write like this. Limit extending towards minus infinity, a raised to the power x is equal to infinity, and a limit extending towards plus infinity, a raised to the power x approaches to 0. Okay. This is the graph of a raised to the power x when a lies in the interval 0 to 1. The function is a decreasing function. Note point 2. If a belongs to 1 to infinity, f of x is equal to a raised to the power x is an increasing function. F of x is equal to a raised to the power x is an increasing function. The graph of the function will be like this. Okay, this is decreasing exponential. This is increasing exponential. I hope it is clear to you. Subhalakshmi, is it clear? Srijit? Then come to logarithmic function. Then come to logarithmic function. ଗୋଟେ minute wait করে একটু পানি দিয়ে দଉଛି। defined as y is equal to f of x is equal to log x to the base a, where a greater than 0 सर क्लास टाइम चेंज करियबनी ना बेटा करियबनी काहे कि ना एटा गवर्नमेंट रो ऑर्डर ना हमें कर परियानी it is defined as y is equal to f of x is equal to log x to the base a where a greater than 0 and a not equal to 1, right? It is defined as y is equal to f of x. For example, y is equal to f of x is equal to log x to the base 5. Y is equal to f of x is equal to log x to the base 9. Y is equal to f of x is equal to log x to the base 0.5 is equal to logarithmic function. Okay. So log x is defined, and then the function is defined. Function is defined when x greater than 0 and a greater than 0 and a not equal to 1. Function is defined when x greater than 0, a greater than 0 and a not equal to 1. Thus domain of the function is audio off audio band karo. Domain of the function is r plus and the range of the function is r. विजय कुमार माझी तुम ऑडियो बंद करो हेलो okay so logarithm functions are of two types domain yes domain ala kon r plus and y is equal to f of x is equal to log x to the base a. If you take a negative value in plus of x, the function will be undefined. This function is defined for positive values of x. Hence, domain of the function is r plus set of positive real number, and the range of the function is r. Domain is r. Srijit, domain of the function is r plus, and the range of the function is r. Okay. Then come to graph of logarithmic function. Logarithm functions are also two types: increasing logarithmic function, decreasing logarithm functions. Logarithmic functions are the inverse function of exponential functions. Okay, when a belongs to 0 to 1, f of x is equal to log x to the base a is a decreasing function. When a belongs to 0 to 1, f of x is equal to log x to the base a is a decreasing function. The graph of the function will be like this. If a belongs to 1 to infinity, then f of x is equal to log x to the base a is an increasing logarithm function. Is an increasing function. So graph of the function is hope it is clear to you. If the base is e, if the base of the function is e, y is equal to f of x is equal to log x to the base e. It is called natural logarithm. It is written as ln x. A graph of ln x is like this. Come to properties of logarithm. Properties of logarithm. First write down log x to the base 10 is called standard logarithm. Log x to the base e is known as natural or Napierian logarithm. Log x to the base 10 is called standard logarithm. Log x to the base is known as natural or Napierian logarithm. And the log x to the base e is written as ln x. Clear? First property log 1 to the base a is equal to 0. Log a to the base a is equal to 1. This implies log e to the base e is equal to 1. That is ln e. Ln e is equal to 1. Third property log m into n to the base a is equal to log n to the base a plus of log n to the base a. Log m into n to the base a is equal to log m to the base a plus log n to the base a. Log m by n to the base a is equal to log m to the base a minus log n to the base a. Log m into n to the base a equals log n to the base a minus log n to the base a. ये प्रॉपर्टी गुड़ा सब आगु तुम लगा पढ़ीच ना नहीं property prove କରିବାକୁ ଦରକାର କି? Should I prove the properties? Do you know the proof? Sir, is this a revision class for 12 students preparing for JEE? No. It is not 12 class students. It is only for 11 class students. Prayas. So guys, do you know the proof of all these properties? Do you want the proof? Vijit? Subhalatni? Property 5. Log of n to the power n to the base a is equal to n log m log n to the power n to the base a equals to n log n to the base a. Property 6. Log a to the base b equals to 1 upon log b to the base a. Log a to the base b equals to 1 upon log b to the base a. Property 7. Log a to the base b is equal to log a to the base m divided by log b to the base m. This implies log of a to the power n to the base b to the power n is equal to m by n into log a to the base b. This is also can be written as ln a upon ln b. Quickly note it down. We'll go to next page. Property next. A to the power log x to the base a is equal to x. This implies e power ln x is equal to x. Property next. A to the power log b to the base c is equal to b to the power log a to the base c. Okay, come to solve couple of questions. Question number 1. Find the domain of following functions. Previous 0.3. Okay, try to solve these three questions. हेलो हाँ हाँ विष्णु को ଆଜି ତୁ ଥେଟରେ କରିବା ଇଏ ବିଷ୍ଣୁ ଆରେ କାଲି ଏକ୍ଜାମ କେମିତି ହେଲା ମ୍ୟାଥରେ ଟୋଟାଲ ମାନେ ଟୋଟାଲ ତୋର ଟୋଟାଲ କେତେ ଆସିଲା 167 ଆଚ୍ଛା 57 ହଁ ଆଚ୍ଛା ୟାର ଶ୍ରବଣର ଆଉ ନା କଣ ତ ସୋମ ଆଚ୍ଛା ହାଇଏଷ୍ଟ କେତେ ଗଲା 213 ସେଇ ଫିଜିକ୍ସରେ ବେଶୀ ବେଶୀ ରଖିଥିଲେ ଆଉ ହଉ ଠିକ ଠିକ ओके to come to question number 1 f of x is equal to log of 2x plus 3. So domain f is the set of all values of x for which the argument of log function should be greater or equal to 0. That here the argument is 2x plus 3. 2x plus 3 is greater than 0. So 2x plus 3 greater than 0 implies 2x greater than minus 3 implies x greater than minus 3 by 2. Implies x greater than minus 3 by 2. So domain of the function is minus 3 by 2 to infinity. Okay. Quickly note it. We'll go to the next page. Then come to the second question. F of x is equal to log of 10 log 10 log 10 x square minus 5x plus 6. Okay, the function to be defined, this should be greater than 0. This implies log 10 x square minus 5x plus 16, not 16, greater than 0. This implies log of x square minus 5x plus 16 to the base 10 should be greater than 0. 10 to the power 0, that is 1. This implies x square minus 5x plus 16 greater than 10 to the power 110. X square minus 5x plus 6 greater than 0. X minus 2 into x minus 3 greater than 0. The critical points are 2 and 3. Plus minus plus minus infinity to 2 union 3 to infinity. So domain of the function is minus infinity to 2 union 3 to infinity. This is the answer to question number 2. जल्दी लिख दिया. The root log of 3x plus 1. Third question. F of x is equal to under root log of 3x plus 1 to the base 0.3. Okay. So function to be defined, under root expression should be greater or equal to 0. Set of all x such that log of 3x plus 1 to the base 0.3 should be greater or equal to 0. Alright. So this implies 0 less than 3x plus 1 less or equal to 1. This implies minus 1 less than 3x less or equal to 0. This implies minus 1 by 3 less than x less or equal to 0. Thus domain of the function is minus 1 by 3 to 0. Your function chapter is over and first session is also over. Second session will start exactly at 9 a.m. and in the second session we should start trigonometry. In the second session we will start trigonometry. Subhalakshmi, is it clear? Trijit? ବର୍ତ୍ତମାନ ଏଇଟା ତମର ଫାର୍ଷ୍ଟ ସେସନ ଓଭର ହେଇଗଲା ସେକେଣ୍ଡ ସେସନ ଆମେ ଷ୍ଟାର୍ଟ କରିବା 9ଟାରେ ସରି ଫାର୍ଷ୍ଟ 9:15 second session will start 9:15 second session is 9:15 to 10:45 okay